Each week, without fail, it returns. A task so mundane, yet so unavoidable. The weight of repetition, unmanageable. It must be done again.
Hello! I want to build a robot to take out the bins. By the way, I'm no coding expert, I'm no robotics expert, I'm no electronic expert, I'm no engineering expert. And if you are one of those, prepare to watch this and laugh and or cry at the probably basic mistakes that I will make. But I like to hack things together and try and get something working, so hopefully we get there. Also, second point, I'm great at starting projects but not great at finishing them. There was my obstacle avoiding robot, there was my air quality temperature, there was my it seems like I got bored and didn't finish this list, but you get the point. And so I'm hoping that making this video will encourage me to see this project through the end. So with my limited knowledge and enthusiasm at the start of a project, I started thinking about how to make this work. Could I add robotics to the actual bin itself? I thought, no. The bin men are slightly careless and it will get broken / stolen. It would have to be very weather resistant. So, not that. My next idea, and I think the one I'm going to try to build, is a robot that will drag the bin out, drop it, and then come back in. And then the next day I put it out and it will go fetch it. So the hard parts here are going to be finding the bin once the bin men have finished with it, dragging and picking up the bin, and probably many more that I've not even thought of. I think I'm going to plan on using an ML model with a camera feed to find the bin, and I'm planning on using very small power non-hungry Pis, so they're not going to have the power to do compute on board, so that's going to have to happen off board, which means we're going to have the control of the robot happen over Wi-Fi, and the camera feed needs to be happening over Wi-Fi. So this video is me making a robot that can be controlled via Wi-Fi and see the camera feed. Welcome to Trip, the three-wheeled robot controlled by Internet Pi. Yes, ChatGPT came out of it and it's a bit of stretch, but I like Trip. Yes, the base is cardboard. Yes, there's tons of tape everywhere. We have the Raspberry Pi Pico connected to the servos. We've got the Raspberry Pi Zero connected to the camera. And tons and tons and tons of tape. And then more tape. And then blue tack. And then dodgy wiring. And then more tape. Let me show you the code. So I'll briefly just walk you through the code. I have this class called movement. Motors are controlled by PWM. And so we initialize the PWM and tell it what pin the motors are connected to. Set the frequency as 50 because that's what the datasheet shares. And we just set it as 0 just to start as this kind of set. So we've got the 5 functions here, 6. We've got forward, and so we set the right motor to 5670. So this number, I tried to read the datasheet and work out what the duty cycle should be, and I couldn't really work it out or get it working. So I just ended up writing a for loop that went through all the different values until the wheel moved. This was the value for forward. This was the value for backwards, or anti and clockwise. So here, this is turning the motors to make the robot go forwards, backwards, left. They both go the same way. Right, they both go the opposite way. Reset and stop, which maybe will stop. Obviously, puts it both to 0. Reset, the same as sleep. I could probably delete that function now. Here I initialize the movement class, and then the rest of the code is about making the Pico into the web server. So this is the web page. We'll come back out to a minute. So here we just connect to the Wi-Fi, and now we're listening for connections. And so if the URL that is requested contains forward in it, we're going to call the forward function in the movement class. Change backwards, we can go backwards, left, left, right, right, and stop, stop. So we're not doing anything particularly fancy, we're just looking for the words forward, backward, left, or right, and then calling that function that's defined further above. So that's the API. This HTML was a way of me just testing it without having to use a control computer offboard, but I didn't want to get to do that yet, so I built this HTML page which the Pico itself serves just as a way of testing. And so there's some styling, CSS, but the main thing to look at here is there's a few buttons which hit the endpoint on the Pico. So as you can see, like make request, we have the direction, and all it does is add from the current location the direction. So it's a bit funny in that it's pinging itself. Then the other bit of code was the bit for the camera, which I'm not going to walk you through because fairly simple, it's just a web server serving images. So those are our code components. Now we put it all together and I think we can test it. The robot's on and I'm accessing the web server with this Chrome window. The camera wasn't on when I accessed it, so let's just refresh and hope we get the camera feed. Yes, the camera feed. Right, let's try and go forward. Hooray, it works. Just click stop. Stop. Good. Gonna go backwards. The cardboard's looking a bit dodgy. Go right. Oh, that's actually left. Okay. Left and right the wrong way round. Go left. It works! Okay, so let's have a debrief. First of all, it's quite slow. Clicking forward takes a while, so stop seems to take a while to work. I think I know what that is. I think there's a sleep in there that shouldn't be somewhere. That's only affecting forward, because the other ones, when I click back and stop, it stops fine. Left is right and right is left, so that's a very simple fix. Also, when I was driving it a bit more, getting it to like point a specific direction was quite difficult, especially when you're just using the camera. So I think what I'm going to do is add a kind of like a move X degrees as opposed to just go until you press stop. Also, I took it outside and there was a problem with the Wi-Fi reach, like it kept cutting in and out. There's going to have to be some kind of Wi-Fi extension or Wi-Fi area that I'm going to have to get. But on the whole, also the cardboard broke and the wires kept coming out and the tape was unraveling. But those things are fixable. So on to Mark 1, because I think this is probably Mark 0, given that it's made of cardboard and tape. Lots and lots of tape. So Mark 1 is finished, and here it is. So I'll go through the upgrades. First of all, it's on wood. No more cardboard. We have a prototype board here instead of a breadboard. Everything's soldered and screwed on rather than using tape, although there is still a little bit of tape here and there. We got a Wi-Fi extender so that the Wi-Fi reach is better. We've got a switch to turn it off and on, and it works much better. I'll show you my code improvements and then we can go test it. So the main improvement is the step direction functions. Big mouthful, but what this essentially does is mean that the robot only goes forward for a set amount of time. So I'll show you the controls on the server side first, and it's pretty straightforward. So I've got for each direction now there's this function. So for example, for the forward one, there's forward step. We go forward, and then if step is greater than 0, we sleep for that amount of time and then we stop. And if step is 0, it just continues. So that's the back end. The front end looks like this. So now we have this controls here to increase the step and decrease the step. Very simple JavaScript. I'm not going to go deep into that. And then we have these extra set of controls here, so you can go forward the set amount of time, which, as you can see from our back end, is the number of microseconds or whatever, milliseconds. Microseconds? 10th of a second, whatever that is. This gives just much greater control. And then I've also added this power off button. So whenever I was having to switch the robot off, I was having to SSH into the Raspberry Pi to turn it off first. Not the Pico. The Pico is fine to switch off, but the Raspberry Pi Zero will complain because SD card, if it happens to be writing or reading and you're powering off, bad things happen. So I was having to SSH in, turn it off, wait for it to turn off, and then flick the switch, and that was getting very annoying. So I made this button which fires a command to the Raspberry Pi Zero, which tells it to power off, and then once I click that, I don't have to SSH in, and then I can flick the switch once it's powered down. And that's the control changes. So now let's go test it outside and have its maiden voyage. Okay, it's outside. You can see it. I've got my controls here. Let's see what happens. I'm gonna just go forward 25. I'm looking at the camera. Is it moving? Yes. Okay. I'm gonna turn right. 25. So I can't actually see the camera that you're seeing, that's recording on my phone. I'm going to get the video off. So all I'm off after, so all I'm doing is just watching this camera. And that's it. Signal. Give me 1 minute, I'm going to go check it. Okay, everything looks okay. Let's just go forward. Right, now I'm going to go move the camera so you can see it go down the driveway. Okay, so everything's back. Move the camera. Now I need to turn right. Stop! Right, camera's now moved. You can now see it all the way, so I just need to go straight. So I'm going to go a bit more tentatively. I'm going to go 66. This is so cool, it's working. Look, I can see the camera feed. It's now very responsive. Perfect. Okay, now let's go forward. I'm aware that I now need to move the camera. Okay, right, let's go. The camera's on its own. My phone's on the wall. Someone could just take it any moment, so I've got to do this quick. I fixed the camera. And I can see out my window, should be able to see the robot any moment. It's maiden voyage, it's gonna make it! Gonna move the camera again. Sorry, I was watching the robot come in. Forgot I was recording. And that, going over the map, is home! Ta-da! So there we go, we've done it. I'm so excited, I'm so happy. I actually managed to finish a thing. So slight more things to tweak. We need the camera to be a bit steadier because it started going wonky. The next thing we need to do is, if it's going to be controlled completely autonomously, is add some awareness of objects around. There was a few times where it's like might start to crash the fence. I had to stop it manually, but it wouldn't be able to do that if it was a computer. So I've got some ultrasonic sensors that I can add to the robot, which will give it that awareness. And then also the whole like trying to find the bin, I think, is the main thing, and also attaching to the bin. So there's still a bit of work, quite a lot of work to go, but I'm happy that we're in our first stage. I hope you enjoyed this video. If you did and you've got this far, please consider subscribing. I love seeing the numbers go up. And see you in part 2.